To find the area of a rhombus or a kite, we can use the formula area equals 1/2 times d1 times d2. d1 and d2 refer to the diagonals of these figures. Now you may recall that we've already found the area of a rhombus. Because a rhombus is a kind of parallelogram, we could also find the area of a rhombus by doing base times height. So this is actually a second way to find the area of a rhombus when we know the diagonals, and it's our first way to find the area of a kite. So let's go ahead and find the areas of each of those figures down below, and then once again we'll attempt the challenge on the rhombus by finding its perimeter. So in this first figure, I'm dealing with a kite. I know it's a kite because I have two congruent sides that are consecutive. They're next to each other. So I do know I'm working with a kite. So my formula for the area of a kite is 1/2 times the two diagonals. Diagonals need to go all the way across the figure, so in this case the diagonals were given to me. You'll see in the next one they did not give me the entire diagonal. And it does not matter which one's d1 and which one's d2 because you're just multiplying. So 1/2 times 14 times 6 gets me an area of 42 square inches. In the rhombus, and I know it's a rhombus because I got 4 congruent sides, I can use the same formula. I don't have the base and height this time, so I cannot use that formula. I don't have any perpendicular sides, but I can use the 1/2 d1 d2 formula. Notice though that the diagonal, or what they gave me as 30 meters, is just half of it. But since we recall that the diagonals of a rhombus, of any parallelogram, bisect each other, I know that entire diagonal is actually going to be 60 meters. So just double check your problems to see if they've given you the whole diagonal or just half of it. I need to be using the whole diagonal. So my whole diagonals are 60 and 80, and then to find its area, same formula as for a kite, 1/2 times d1 times d2, and if I reach for a calculator to do that calculation for me, I get an area of 2,400 meters squared. Okay, let's go ahead and attempt the challenge part of this problem. Let's just do one of them though. Let's do the rhombus part, and I want to find its perimeter. To find perimeter, I need to add up all the sides around the figure. And I don't know any of the sides right now, but the good news is all the sides are the same, so I don't need to worry about finding all of them. Let's just find one of them, and then I can multiply that answer by 4. So what I'm going to look at, as we've done on many of these problems up till now, I'm going to look at just one triangle in there. I know two sides of that triangle. One side's 30, one side's 40. That was what was given to me. And then I also recall about properties of a rhombus that the diagonals are perpendicular to each other, meaning I do have a right angle formed, which means I have a right triangle. So as you've probably figured out by this point, once again, we're going to be doing Pythagorean Theorem to find a missing side. So 30 squared plus 40 squared would equal the hypotenuse squared, which is the unknown to us this time. I'm going to skip the math on it. I kind of already did it off to the side. If you need to do the math, pause the video and try this. Otherwise, trust me, that missing side is going to be 50. In this case, the units are meters, so 50 meters. And as we said, all the sides, since we have a rhombus, are 50. So I can label all of the sides as 50 meters, which means the perimeter is going to be 50 times 4, or just add 50 to itself 4 times, to get me a perimeter of 200 meters for this figure.